Nearly 2 years ago now, I kicked off this crazy project. The goal was to harness high pressure air from my turbocharger based jet engine and create supersonic flow through a converging-diverging nozzle. Being a relatively novel concept, I had to develop the prototype from fundamentals and validate the design through experimental testing. In April of 2024, I posted the first supersonic run of my initial prototype. You could only barely see the shock diamonds, and combustion was completely sporadic. So I CNC machined a proper nozzle, refined the combustor design, and gathered critical performance data through cold flow tests. I experimented with various water injection methods, leading to significant improvements in temperatures. I incorporated all of these changes into the current design. When I tested this new prototype, this happened. What is up guys, Lachlan here. So last weekend I got some incredible footage of the new rocket design. I was testing this CNC machine nozzle, which was a massive upgrade to the last one. I'll show you all the footage later in this video, but for those who are new to the channel, I just wanted to give a quick introduction to the project and a bit of a walkthrough around this engine just to show you how it works and what I'm actually doing here. So I actually built this engine years ago as part of my engineering thesis project, which I was developing a dual fuel concept that ran on both methane and traditional jet fuel. And I was comparing the emissions of that to just running on jet fuel. Now, since then, it's turned into more of a broader propulsions testing platform, including the one for this auxiliary combustion chamber, which is more of a passion project into the world of supersonics. Now, if you're interested, I can do a walk around video of the full setup, including the control systems, the high voltage ignition system, and also the oil system. But for now, I just wanted to give a quick overview of how the engine works. So essentially I've got a turbocharger which simulates the compressor and turbine sections of a jet engine. And then you've got the main combustion chamber down here where LPG is injected into the bottom going upwards. Now, the part that's a little bit unique with this engine is I'm actually taking bleed air from the compressor here and funneling that through an auxiliary combustion chamber. Now, the benefit of that is you get much higher pressures than what you do from a traditional afterburner, as most of the pressure is already lost into the turbine. Now, I'm definitely interested in doing an afterburner on this one day, but I was a little bit disappointed with the inability to create shock diamonds. And so that's actually part of the reason why I've been testing some different converging-diverging nozzles with this auxiliary combustor. You get much higher pressure ratios using this method than you do coming out of a traditional afterburner. Now, as you can see from the nozzles, the one that I've tested last weekend is significantly smaller than the one that I actually want to test. I have done some cold flow testing on this nozzle, and you need to inject a significant amount of water in order to maintain the turbine inlet temperature in recommended ranges. Now, in my previous video, I actually did a really detailed walkthrough of the water injection system. So if you're interested, go check that out. Since then, I have actually added an additional injector into the primary zone down here. So yeah, let's go and take a look at the auxiliary combustion chamber on the desk. So this is the main auxiliary combustion chamber casing. It's basically just stainless steel pipe, which is less than ideal in terms of the threading, but it's easy to change different fittings and it's a lot cheaper than doing flanges. As I improve the design, I'm definitely going to be using flanges though, but this has been really useful for R&D. Now, this is actually the first nozzle that I made, which is essentially just a tack together reducing flange with a fitting. You can see that this is more of a combustion liner style chamber that you would see in a traditional jet engine combustion chamber. It didn't work overly well just because it was difficult to get the right sizing of the combustion liner with standard tube sizes, and the nozzle size was a little bit larger than what it needed to be. It needed to be something more that size. Now, since then, I've been testing with this CNC nozzle, which is a little bit larger again, and I've been experimenting with different styles of flame holder. Still less than ideal, but it's been working alright just for testing. It might be obvious to some, but the large mass flow rate of this nozzle is definitely going to present a problem with this casing diameter. This casing's definitely more suited to the smaller nozzles, so I might need to upgrade this before we can get good combustion stability with this, but I'm going to give it a crack anyway and just see how we go. So then I've got a basic high voltage igniter that I use for this, and that just grounds through this stainless bolt here. And then the final piece of the puzzle is the gas injection, which I basically just use stainless steel tube, and I inject it radially just because of the high pressure. If I injected it axially, it would blow through and you wouldn't get very good mixing. I've definitely had a lot better success with radial injection. So now I'll play the full video from last weekend testing with this nozzle, and yeah, I'll show you the full run for it. Now, as you can see, that ran way better than the original one. The combination of changes made a huge impact. So I went from the DIY style nozzle to a CNC machine nozzle. I went from the combustion liner style to more of a flame holder style. And finally, I just made some tweaks to the LPG injector just to get a bit more mixing pre-combustion. Now, going from here, I definitely want to still test with the larger nozzle. And I've also got some other things going on in this project, such as going to a fully autonomous engine. It's a fairly large endeavor. There's a lot of pieces to it. Basically, I'm automating most of the ball valves with stepper motors, but I've also got a large linear actuator that's going to actuate the airflow going to the auxiliary combustion chamber. If you're interested in that sort of stuff and also want to see things like the computer system that I'm using and the graphic interface for the temperature and pressure sensor data, as well as the actuation control, then let me know and I can make some videos of that while I'm developing it. But yeah, that just about wraps up today's video. So if you enjoyed this sort of content and you like this project, please subscribe, hit the little notification icon and leave a comment. I'm always happy to have a chat. Anyway, that does it for today. Thank you for watching and I'll see you in the next video. Cheers.